Hi guys, welcome to Geometry, Chapter 2, Lesson 1. We're going to start on your journal. This is, I'm going to try to draw right on here. This is page 37 in your student journal. So if you want to have that open to go along with me, please do that. Okay, and then also in your book, we're going to be writing, this is page 66. This is where it starts. But this way you have the journal notes already ready to go, and we're going to talk about this. Now, we have 3 goals for section 1. Write conditional statements, use definitions written as conditional statements, and number 3, write biconditional statements. And we're not going to do truth tables, so it is listed as an objective, but we're not going to do that page. Now, on these note-taking, we have definitions, which you already wrote down. A conditional statement is a logical statement that has 2 parts. A hypothesis, which we are going to from now on call P, and a conclusion, which we will call Q. Why? Well, the first reason is because they're big words and we don't want to write them 10 times. So instead of saying hypothesis, we say P, and conclusion, we say Q. When a conditional statement is written in if-then form, it looks like a sentence. But mathematicians are lazy. We don't want to write out a whole sentence if we could just put a couple of symbols. Okay, so the if part is the hypothesis, and the then part is the conclusion. So in words, this is actually what it looks like. If P, whatever P happens to be, then Q. We can also write it with an arrow, okay? And so in symbols, what this means is that P implies Q. That would be the word for the arrow. For instance, if the door is unlocked, that would be my hypothesis, then I can open it. That would be my conclusion. If the door is unlocked, then I can open it. Nothing more than that. But if you want to make some little notes yourself, maybe come up with your own little conclusion here. Write that in your journal. Again, still definitions. Now, negation simply means the opposite. Okay, so when we talk about negation, anything you want to say, like not black, well, the negation of not black is not black. Or like in a double negative, you can think of it as black. So negation is the opposite. In fact, I think I'm just going to do a highlight here. I can get the highlighter to show, but it's not letting me do that. Okay, it doesn't like the highlighter, but that's all right. I'll go back to drawing. So it is the opposite of the original statement. To write the negation, again in symbols, you can either write the word not in front of your hypothesis, or you'll put it in the verb, or you can hardly see this, but this is a tilde. So that means not P, not P, and P is our hypothesis. Okay, so again, definitions. Now, related conditionals. So related conditionals are these right here. One's called the converse, and one is called the inverse. And basically what you're doing is you're switching your P and your Q. So in words, if you start with if P, then Q. So if the door is opened, if the door is unlocked, then I can open it. That would be P implies Q. However, if you're going to write the converse, you're going to switch those. You're going to say, if I can open the door, then it's unlocked. So it's if Q, which is your conclusion, then P, which is your hypothesis. So if you can switch them around and still have a true statement, that is a converse. Again, you can see your symbols are switched here, right? Now we have an inverse, which means the negation of your original clue. So you negate. Here you exchange, here you negate. So instead of saying, if the door is locked, you would say, if the door is locked, because that's the opposite of unlocked. And then you would say the opposite, then I can't open the door. So that's how you do not P implies not Q. If the door is not locked, then I can't open it. Those are converse and inverse. So we'll go to the next page because this is still section 1. The other one that you're going to write is called the contrapositive. It's a big word, but in other words, there's only so many combinations you can do. You can do if P, then Q, if Q, then P. If not P, then not Q. And so what you can do is you can switch them and negate them. So if not Q, then not P. So it is the negation of the converse. You'd say if not Q, then not P. So a conditional statement and its contrapositive are either both true or both false. So they're the same thing logically, and similarly, the converse and the inverse go together. Those are also both true or false. So we would say that those are equivalent statements. Okay, equivalent statements. So the ones we're going to put together, I'm going to do a different color here. So the ones that are going to go together, okay, is the conditional. Please write this down. I'm not great with this pen. The conditional and the contrapositive are the same. Maybe put them in a box, something like that. And then also the inverse and converse are equivalent. Inverse and converse. Because what we're going to talk about is what is logical, okay? Equivalent statements. So now if you're following along in your book, what we're going to do is do a couple of examples, okay? And some of these have to do with definitions, like perpendicular lines and a biconditional statement, things like that. So I'm going to go through the teaching examples right here from your student journal thing. This is called the dynamic classroom. It's in Big Ideas. So if we were in the classroom together, I'd be doing this on the board. Use red to identify the hypothesis and blue to identify the conclusion. So here, the hypothesis is the P and the conclusion is the Q. So here's your solution. All birds is the P, feathers is the Q. And then rewrite it in if-then form. If an animal is a bird, then it has feathers, would be the conditional statement. Second example, you are in Texas if you're in Houston. So you would say, you are in Texas, that is your hypothesis. And if you are in Houston, that's your conclusion. If you're going to write it in a sentence, you would say, if you are in Houston, then you are in Texas. So it's not always exactly in the same form. You'll see how those are switched. But that is, something we can do. Here's another example. Write the negation of each statement. The ball is red. So hopefully you recognize this is the opposite will be the ball is not red. Just write it out. Okay, so the cat is not black. So instead of saying not black, you would just say the cat is black. Third example. Okay, let P be you are a guitar player, and let Q be you are a musician. So now we're going to write each one of these. And this right here is something really good to have in your notes. The conditional statement, P implies Q, is if you are a guitar player, then you are a musician. That's conditional. The converse would be, if you are a musician, then you are a guitar player. The inverse is, if you are not a guitar player, then you are not a musician. And the contrapositive, if you are not a musician, then you are not a guitar player. And I will write those definitions. So you can see the conditional and the contrapositive are the same. They're both true. But the converse and inverse are both false. Example 4. Decide whether each statement about the diagram is true. Explain your answer using the definitions you have learned. So on page 68, you'll see a picture like this. The definition of perpendicular lines is, if two lines intersect to form a right angle, then they are perpendicular. If two lines form a right angle, then they are perpendicular. Okay. So what's true about this? Is it true that AC is perpendicular? That's the perpendicular sign to BD. Yes, that's true. We see it's marked right here. Is it true that AEB and CEB are a linear pair? Yes. Linear pair means that they're adjacent and they form a straight line. EA and EB are opposite rays. Nope, they're not opposite. They're not on the same line, therefore it is false. So you are using these same examples, and we're going on to number 5. Okay, so we're going to rewrite some stuff. Rewrite the definition of perpendicular lines that I just told you as a single biconditional statement. Now, biconditional is slightly different, and what it means is both the conditional and the converse is true. So you can actually go both ways. If the door is unlocked, then I can open it. If I can open it, then it's unlocked. So that means biconditional because it means it goes both ways. Now there's this, I don't know how I can write on this, but there's a funny little symbol here that is a double arrow. It looks like an arrow with little carrots on both ends, and that means biconditional. It's also in words written as if and only if. So if and only if is a biconditional statement, and it means that it's not just P implies Q, it's also Q implies P. So here is a definition. If P is two lines intersect to form a right angle, and Q is they are perpendicular lines, then we're going to use red to identify P and blue to identify Q. And then we're going to write the definition. So the if statement is two lines intersect to form a right angle. The blue or conclusion is they are perpendicular lines. And so your definition or the converse would be the opposite. If two lines are perpendicular, then they intersect to form a right angle. Now, if I was going to write the biconditional statement, I would use those words if and only if. So this means P implies Q and Q implies P. That's the symbol I was talking about. So here we go. Two lines intersect to form a right angle if and only if. That means biconditional. They are perpendicular lines. If and only if. So there you go. I've got lots more examples, but we're just going to do one more before I let you try on your own. And, oh, that's the truth table, so we're not going to do that one. So if you want to find this dynamic classroom, the examples that I just showed you, and we just went through notes in your journal, page 36 to 37, and in your book, we just went from page 66 to 69, and that's our first section. You're going to do your work in the Big Ideas Math platform, and it should be open now. So good luck. And if you rewatch this video as many times as you need, but if you do want to find it, I do believe you can see it in your dashboard like this, and it's in the dynamic classroom.